Hello friends, today we are discussing some important reaction related to alkane. How alkane can be prepared, how alkane is used in different chemical reactions, what are the different name reaction related to alkane, its preparation and chemical properties. Generally we will discuss only the name reaction related to alkane. So without wasting time, let us discuss some important reaction related to alkane. First reaction, that is the name reaction, this is called Clemenson reaction. This reaction is called Clemenson reduction. What is this Clemenson reductions? In Clemenson reductions, either aldehyde undergo reductions in presence of zinc amalgam and HCl convert to alkane. If you take ketone also, if you take ketone, same reagent, it convert to alkane. If you take amide also, same reducing agent, convert to amine. So this is very important to convert aldehyde, ketone, this is your aldehyde, this is aldehyde, this is your ketone, and this is your amide, can be converted to corresponding alkane. This is very important name reaction, and this reaction is called Clemenson reductions. Preparation of alkane from aldehyde, ketone, like this. Here same. Here no change of amino group, but CO convert to CS2. Here reduction. Here in this case the loss of oxygen takes place and the compound become alkane derivative. So this reaction is called Clemenson reduction. Second name reaction, that is decarboxylation. Decarboxylation reaction, here mainly we will discuss decarboxylation of acid, carboxylic acid. Let us take one salt of carboxylic acid. When it is heated in presence of soda lime, mixture of sodium hydroxide and calcium oxide, the major product is your alkane and side product is your sodium carbonate. So here this is your alkane. Decarboxylation, loss of carboxyl group, loss of carbon dioxide, that's why it is called decarboxylation. This is a salt of sodium salt of carboxylic acid when heated in presence of soda lime, forming alkane. Alkane can be prepared by this process. So this process we can prepare also benzene aromatic compound. If you take aromatic carboxylic acid, let it be like this, CONA, same reagent, on heating convert to benzene. So by this way we can prepare aliphatic alkane or aromatic alkane by taking sodium or potassium salt of carboxylic acid. Okay, this is called decarboxylation, loss of carbon dioxide. Then preparation of alkane can be done by Grignard's reagent, Grignard's reaction. This is called Grignard's reaction using Grignard's reagent. RMGX, this is called Grignard's reagent. Grignard's reagent, when treated with water, it produces alkane. Main product is alkane, side product will be MgX and OH. This is your alkane. Alkane can be prepared in this way. So alkane can be also prepared by using alcohol also you can get also. If you take RMgX, if you take alcohol, you can get also same alkane, and side product is MgX and OR. This is also alkane. So Grignard's reagent reacts with water or alcohol forming alkane. This reaction is called Grignard's reaction. Cole's electrolytic method. This method also useful in the preparation of alkane. If you take salt of carboxylic acid, when undergo electrolysis, it produce alkane, and your side product is your sodium hydroxide and carbon dioxide and your hydrogen gas, all will be formed. How this product will be formed? Here what happens, if you see the mechanism, here first step, this salt when dissociates produce cation and anion, and this anion move towards anode, loses electron, produce RCOO, which is unstable. When it decomposes, loss of carbon dioxide, here two molecule use and produce RR. Here it takes place at anode, and the result is alkane. So alkane is produced at the anode. Oxidation. This reaction is called oxidation reaction of anion. Here remaining Na plus reacts combine with electron, that is addition of electron, reduction produce Na. Then Na reacts with water forming NaOH and hydrogen gas. So this is takes place at cathode. This reaction takes place at cathode. So by the electrolytic reduction of salt of carboxylic acid, the product is alkane. The main product is your alkane. This is your alkane. So this reaction is called Cole's electrolytic method, preparation of alkane. Halogenation of alkane. If you write this thing also, it is possible. Here suppose methane in presence of chlorine, in presence of light, produce methyl chloride, dichloromethane, trichloromethane, and carbon tetrachloride form, because it is a substitution reaction of halogenation. Here halogen gets substituted in place of hydrogen, forming monochloro, dichloro, trichloro and tetrachloro alkane derivative form. This reaction is called halogenation. And if this reaction in presence of iodine is very slow, it undergo a reversible change, so very slow reaction. So product is very less, amount will be less, because the reaction is slow, because it's reversible. So amount of iodoalkane is less. So to get more amount of iodoalkane, so reaction can be done in presence of nitric acid. If it will be done nitric acid, then the HI, it reacts with HI forming iodine. So reaction will be, if HI is formed, this HI will be converted to iodine by adding nitric acid. So the reaction will be in the again forward direction. So to increase the rate of reaction, to increase the speed of reaction. So if you add nitric acid, then the reaction will be in forward direction and producing more amount of iodoalkane. So this is the called halogenation, formation of halogen derivative of alkane. Nitration, same. Nitration generally takes place, your alkane reacts with concentrated nitric acid on heating, result is nitroalkane. This is your nitroalkane is formed. Methane reacts with, but if you take aromatic also, aromatic compound, nitration takes place in presence of nitric acid and sulfuric acid, result is nitrobenzene. This is also called nitration of aromatic compound, and this is called nitration of aliphatic compound, that is alkane. Both are called nitration of alkane, either aliphatic or aromatic. This is the difference. Formation of both, the result is nitroalkane and nitrobenzene. But here pure nitric acid is used, here mixture of nitric acid and sulfuric acid is used. This is the difference. This reaction is called nitration of alkane. Sulphonation, same. You have to use like this. Methane reacts with sulfuric acid, constant sulfuric acid on heating. Result is HSO3 plus water. Okay. So result is alkyl bisulfate. Alkyl bisulfate. Alkyl bisulfate is formed with the loss of water molecule. So formation of alkyl bisulfate is formed when alkane reacts with sulfuric. If you take propane, same sulfuric acid, here reaction will be SO3H and CO3. Same bisulfate compound is formed. So this reaction is called sulphonation. Then very important name reaction is Sabatier-Sanderes reaction. It is also used in the preparation of alkane. Is like this. If you take alkene and treated with hydrogen in presence of nickel and hydrogen, and in present nickel metal, the result is alkane, formation of alkane. If you take also alkyne, undergo also reduction, here two molecules required. On heating, here nickel, on heating, result is also alkane. And this reaction is called Sabatier-Sanderes reaction. That is a reduction of alkyne in presence of hydrogen, and the catalyst generally nickel is used. This reaction is called hydrogenation of, this reaction is called hydrogenation reaction, and this is called Sabatier-Sanderes reaction. Very important reaction in alkane, that is your Wurtz reaction. Haloalkane reacts with sodium metal. Formation of alkane is obtained with the loss of halides, sodium halides, and this reaction is haloalkane convert to alkane when treated with sodium. But here condition, you have to use dry ether is used as a solvent. So in ethereal medium, sodium reacts with haloalkane forming alkane. This is called alkane, and this reaction is called Wurtz reaction, formation of alkane from haloalkane. This reaction is called Wurtz reaction. Uff-Kishner reduction. This is a very important reduction of your aldehyde and ketone. Here what happens? The hydrogen derivative of aldehyde and ketone, hydrogen derivative of aldehyde or ketone, when reacts with potassium hydroxide and your ethylene glycol, the result is your alkane. Result is alkane. Main product is your alkane. This is your alkane is formed. Similarly, if you take hydrogen derivative of ketone, same potassium hydroxide and ethylene glycol, the result is also alkane. This is also alkane, and this reaction is called Uff-Kishner reduction. It is a very important specific reaction in the preparation of alkane from aldehyde and ketone using hydrazone derivative of, this is hydrazone, this is called hydrazone. Hydrazone derivative of aldehyde or ketone when reacts with potassium hydroxide and ethylene glycol forming alkane. This reaction is called Uff-Kishner reduction. So today we discuss some important chemical property and some preparation of alkane using some name reactions. So you practice it, and if you have not subscribed our channel Chemistry Goal, please subscribe it and share the video to your friends. And if any question if you have, please share your question in the comment box, and continue watching the video. Okay, thank you all.